Hello students, welcome to the channel. In today's video, we'll discuss the basics of trigonometry. So let's begin. So trigonometric ratios are known as sine, cos, and tan. These are the basic trigonometric ratios. And you can understand them from a right triangle. Let's say I have a right triangle. Let's call it A, B, and C. And let angle B be theta, right? Angle C be 90 degrees, and angle A is just angle A. So the side opposite theta is known as the opposite side, and the side adjacent to theta is known as the adjacent side, while the side opposite 90 degrees is the hypotenuse. So the first thing to do is to choose the hypotenuse, that's the side opposite 90 degrees. And then from the remaining two sides, the one opposite to the angle we are looking at is the opposite side, and the one connected to the angle is the adjacent side. Then the sine of theta is defined as the opposite side divided by hypotenuse. The cos of theta is defined as the adjacent side divided by the hypotenuse. And the tan of theta, which can be written as the sine of theta divided by the cos of theta, is simply the opposite divided by the adjacent. Now, there are two special right triangles that we are particularly interested in. The 30, 60, 90 triangle, where the side opposite 30 is 1, the side opposite 60 is √3, and the hypotenuse is 2. So any 30, 60, 90 triangle will have the sides in the ratio 1, √3, and 2. So if I were to say sine 30, then sine 30 would be opposite divided by hypotenuse. So that's 1 by 2. Cos 30 would be adjacent by hypotenuse. So that's √3 by 2. And tan 30 would be opposite by adjacent, which is 1 over √3. If you look at the triangle from 60 degrees perspective, so let me do that. If we look at it from this 60-degree perspective, then we notice that the opposite is this side, the adjacent is this side, and the hypotenuse is the same. So now sine 60, remember that this was √3, this was 2, and this was 1. So now sine 60 is √3 by 2, cos 60 is 1 by 2, and tan 60 is √3. The other special right triangle that you need to remember is the 45, 45, 90 right triangle, where the sides are in the ratio 1, 1, and √2. Because the two angles are the same, the sides opposite them will also be the same. So 1, 1, and √2. So here you can see that sine 45 will be 1 by √2. Cos 45 will also be 1 by √2, and tan 45 is 1. Now, do you need to remember these special triangles? Not really, because the first page of the math section of the SAT, both for the no calculator and the calculator, has this data given to you. It has information on circles, on rectangles, and so on. And it also has these two special right triangles given to you with the sides, right? So the side opposite 30 is x, opposite 60 is x √3, and opposite 90 is 2x. So I can find any ratio, sine, cos, or tan from this. And similarly for the 45, 45, 90 triangle. So you don't really have to memorize the values of these ratios. Okay, so let's try a sample question. What is the length of side AC in the right triangle above? So we are looking at side AC, which is adjacent to this angle 30. So if I look at cos 30 degrees, it would be AC by BC, right? And cos 30, we know, is √3 by 2, right? From the trigonometric ratios that we looked at. So AC by BC is 4. So AC is 4 √3 by 2, which is 2 √3. So my answer for this question is option B. Okay. Now let's do another sample question. If tan theta is 2/3 and theta is between 0 and 90, what is the value of sine theta? So let me draw this triangle. Let's say this is theta. So if tan theta is 2/3, then I can say that this side is 2 and this side is 3, right? Because tan theta is opposite over adjacent. So opposite is this side and adjacent is the side next to it. So 2/3. So what will be the hypotenuse? It will be the square root of 9 plus 4 by Pythagoras theorem, which is the square root of 13. So now sine theta, which is defined as opposite divided by hypotenuse, will be 2 divided by root 13, which is option A, right? Okay, so that was, yeah. Now we also need to remember some relationships between trigonometric ratios, and a relationship that is particularly commonly tested on the SAT is this relationship. If there are two angles X and Y such that the sum of the angles is 90 degrees, then sine of X is cos of Y and cos of X is sine of Y. And you can see that this is quite obvious because if I have a right triangle and if this is X and this is Y, then by the property of a triangle that the sum of the three angles is 180 degrees, X plus Y has to be 90 degrees. So let me call this A, B, C. So then I can say that sine X will be AB over AC because opposite over hypotenuse, and cos Y will also be AB over AC because for cos Y, the base is AB, Y, right? So sine X happens to be cos Y, and similarly cos X happens to be sine Y. Right. The other important identity to remember is for any angle theta, sine squared theta plus cos squared theta is always 1. So let's use the same triangle, but this time we'll just work with one angle theta. So let's say that this angle is theta. Then sine theta is AB by AC and cos theta is BC by AC, right? So sine squared theta plus cos squared theta is AB squared plus BC squared by AC squared. But AB squared plus BC squared by Pythagoras theorem is AC squared. And so this ratio is always 1, right? So these are the things to remember. Okay, let's do a sample problem. The angles shown above are acute. Acute angles meaning less than 90, and sine A is cos B, right? So we know that if sine A is cos B, then A plus B has to be 90 degrees, right? We just discussed that. If A is 4K minus 22 and B is 6K minus 13, then what is the value of K? So 4K minus 22 plus 6K minus 13 would have to be 90 because A plus B would be 90. So 10K minus 2 and 1, 3, 35 is 90. So 10K is 125. So K is 12.5. So the value of K is 12.5. Okay, we should also know the ASTC rule, which you can remember by the abbreviation that I was taught at school. All students ticket collectors, right? So just remember this ASTC. that tells me that in the first quadrant between 0 and 90 degrees, all the ratios, sine, cos, and tan, all the ratios are positive. In the second quadrant from 90 to 180 degrees, only sine is positive. In the third quadrant from 180 to 270 degrees, only tan is positive. And in the fourth quadrant from 270 to 360, only cos is positive. So this is useful to find the sine of angles greater or cos or tan of angles greater than 90 degrees, right? So let's say I need to find the sine of 120. The sine of 120, I can always work with multiples of 180, right? So sine of 120 would be the sine of 180 minus 60. What about the sine? The sine here, SIGN here would be positive because in the second quadrant, which is where 120 lies, sine is positive. So that would simply be sine of 60 degrees, which is root 3 by 2. So the sine of 120 is root 3 by 2. Okay, what about the cos of 210? This would be the cos of 180 plus 30 degrees, right? Because 210 is here somewhere, 210. So this angle is 30 degrees. So adding with 180 or subtracting from 180 as we did for sine 120 will give us the same values, except that we will have to check for sine, SIG and sine. Now, in the third quadrant, cos is negative. So this number will be negative of, so I'll just make that clear. Cos of 180 plus 30 will be negative cos of 30. So here, whatever is cos 30, I'll take a negative sign with it because we are in the third quadrant where cos is negative. So cos 30 is root 3 by 2. So cos of 210 is negative root 3 by 2. So the ASTC rule was not tested earlier, but in a recent administration, they asked the value of cos 120, right? They drew a graph and they asked you the value of cos 120. Let me just draw it here. So you had to know the ASTC rule to solve that. So cos 120 is basically cos of 180 minus 60. And that would be negative cos 60 because in the second quadrant, cos is negative. So that's minus half, right? Minus 1 by 2 because cos 60 is 1 by 2. Right, so that was a basic video on the fundamentals on trigonometry. Hope this was useful. If it was, hit like and subscribe to the channel. Let me know in the comment section what other videos you'd like me to upload. I'll see you guys in a new video soon. Take care. Bye-bye.